to you.
Yes, good afternoon from India, Mumbai. And Adam, I'm really proud of you that you have carried forward all your learnings to Saudi Arabia and other parts of this thing. And I was very proud of what you have been doing in the field that we were doing for the last 30 years, 40 years in the field of continuous improvement. Congratulations. You won't. Well, there's nothing much about me to be introduced. They call me Dr. M. I wouldn't know why. But then I've been in this from the year 1989, and my sensei was Sensei Masaki Imai. I've been working across industries, and we are together in the field of Deming, etc. And you chose the right topic. And I am a patient. I am in the courtesy in the arms of the healthcare professionals. And whatever you're talking about, I'm experiencing it firsthand. And I'll take forward your recording to the group that are dealing with me. And thank you very much for having this session. And I'm very proud of you, Alam.
Thank you, Dr. Mohan. Thank you, Dr. Mohan. I've learned a lot of these things and concept and mindset from your sessions itself. So let's start. Let me share my screen first, and then we'll straight away deep dive into the session. So can you confirm if you can see my screen? Perfect. Perfect. Let me put it on a presentation mode. All right. So again, welcome everyone, and thanks for joining in. I know it's a weekend and you have taken this time out from your busy schedule. Will not take very long time. We'll finish this on time, right at 2 p.m. or even before it. So our topic today is systems approach inspired by industrial engineering and lean principles, and how do we use this to enhance patient experience. Now, this is very interesting topic. Usually very misunderstood concept in a hospital environment, when actually we work with people who have not come from engineering background, and it looks a little bit complicated, but we'll try to simplify today, because our aim is not to make you experts in lean and six sigma and tools. We're not here to make you, green belt, black belt and master black belt. Our aim is to create a mindset of continuous improvement. How do we improve in any environment, be it industries like manufacturing or oil and gas, or be it a service provider like a hospital or IT or anyone. So you may get a chance to work in any of the industries, but the principles will remain the same. But now today specifically we'll talk about how these concepts and these methodologies and the mindset applies to healthcare environment, especially in hospitals. So I'll not talk a lot about me. So I come with around 18 plus years of experience. For more than a decade, until 2020, I worked with manufacturing and engineering industries and oil and gas. And then in 2020, when actually the corona started, I moved to the hospital environment. I have a bachelor in mechanical engineering, MBA in operations. I'm a Six Sigma Master Black Belt. So I'm a lean practitioner. I'm not an expert in all the tools. So every day I'm still learning, and I keep studying, and I join sessions like you have joined these sessions. I join other sessions because there's always something new to learn. So it's a tale of two journeys. Let me start with, when I traveled to Orlando, and I'm usually scared of taking flights. What if, it crashes? What are the chances of surviving and all that? Many of us have a phobia of flying, and I'm one of them. But let's look at the stats. Jeddah to Orlando, the distance is around 11,240 kilometers, and it takes around 15 or 45 minutes of flight when you take this. Now, what are the chances of dying in this journey? The risk of dying while traveling by airplane is 1 in 13.7 million. This is what the risk is. So I was reading it. If with this rate, with this probability, if for example you are the unfortunate one, who happened to die, you need to take one random flight every day, and you need to take that flight for another, I think, 50, 70 years. Then this big chance becomes a little bit more statistically valid for you to have a to involved in a crash. Now compare this with the hospital visit. How does the hospital visit looks like? So you go to a hospital and you go through a simple journey, which is registration, consultation, lab, pharmacy, and discharge. And statistics says around 1 in 10 patients is harmed in a hospital. More than 50% of this harm is preventable, and preventable medical accident risk is 1 in 300. So when you go to a hospital, you visit multiple places in a hospital, you go to a lab, pharmacy, discharge, and consultation, and you acquire some of the bacterias, viruses, or any other thing which is spread in the hospital. So the chances of getting harmed in a hospital is 1 in 10. This 1 in 10 is especially talking about the patients who are admitted in a hospital. So very often it happens that patient goes to a hospital for a surgery and they get admitted in a hospital. They stay the hospital in for another 2 to 3 days. And when they come home, they either get some other kind of infection is even not related to their surgery or to their the treatment that they were admitted for. So sometimes they get a surgical site infection, sometimes they get some other kind of infection. So you can imagine around 1 in 10 patient is harmed in a hospital, and more than 50% of this harm is preventable. And now, when you compare these two journeys, you might feel a little bit scared visiting a hospital, getting admitted in a hospital, versus actually taking a flight to some far destination. And this really is a stark comparison that how much we need to work in a healthcare industries and how much we need to learn from other industries like airline industries, where the aeroplane is so complex machine with thousands of components working together with each other in sync. And even if one component fails, it might have an impact on integrity of other components, and it may have some catastrophic effect as well. So the lesson from this slide is that in the hospital is also like an airplane. Hospital is also made of multiple components. Hospital is made of multiple components working together. The nurses, doctors, technicians, the multiple non-clinical department admin staffs, they all need to work together to take care of to take care of the patient who is in the hospital, and make sure the patient who came to the hospital leave the hospital without getting any additional infection or without getting harmed. Like an airline industries ensures that when we take a flight, we land safely without getting harmed. Now, at any point of time, if somebody wants to add anything, please unmute your mic and you can add and you can speak. All right. So aviation teaches us one lesson clearly. Safety is not achieved by good intentions alone. It is designed into the system. Very often when I go to the conferences, especially talking about patient experience in hospitals, people talk a lot about empathy, showing respect, taking care of patients, talking politely, and talking about patient should not wait, patient should go through the journey smoothly. We all talk about what intentions we have, and very rarely I have seen anyone talking about how do we solve the problems you're talking about. I mean, if you attend any session this year or you attend any session next year, the topic will be the same, the theme will be the same. Everybody will talk about the same thing, that we need to show empathy to patient, we need to understand their pain, we should not make patient wait, we should make patient go through the hospital journey smoothly. It is the same talk. Very rarely we're talking about how do we address these problems. Now, this is the reason I have said this multiple times. Enhancing patient experience requires a fundamental shift in how we view the hospital. It is not a hotel for a sick people. It is a complex, high-risk socio-technical system that requires the same engineering rigor as a nuclear power plant or an international airline. Now, in this session today, we'll go through some of the concept. First is improvement is a science. It doesn't happen on its own. It doesn't happen if we think good, if our intentions are good. If our intention is not to harm a patient, it does not mean that patient will not be harmed. If our intention is not to make a patient wait, it does not mean that patient will not wait. So the improvement cannot be done, just by thinking, by having good intentions. We need to apply the science. Respect for people, of course, it's inherited part of any improvement you do. We'll talk about balancing demand and capacity. That is one of the important concept is applicable in a hospital. We'll talk about batch processing versus single piece flow and data driven decision making. So again, coming to a very famous quote by W. Edwards Deming, hopes without a method to achieve them will remain mere hopes. It is not enough to do your best. You must know what to do and then do your best. So let's look at this iceberg model, and I'm just trying to use this to explain the systems thinking. So we have four layers. The first layer is events, which is visible to everyone. The second is underneath is a patterns and trends. Then we have a structure, and then we have mental models. So very often when we look at the problems, the issues in the hospitals, which is visible to us, are the events. And then underneath we have multiple layers. Now, if we want to address the issues which are visible to us, we need to target the structure and the mental models. So let's look at this. The events are what is happening. The trends are basically what is the trend over time, and the structure is how the patterns are related, and the mental models are very important. Especially, I have seen it in a hospital. We'll see very shortly an example that very often mental models are actually the root cause of the problems. So let's look at it. Let's look at it with an example of an emergency department. So we have an emergency department, and we can see the waiting room is full of patients, and the patients are waiting for hours. This is the visible problem that we can see, and the patient is waiting on a stretcher in the hall. These are the visible problems, the events of this emergency departments, of this process. Now let's look at the patterns and trends. Let somebody like me or somebody in a quality or a statistical department looks at the trend, and it tells that person that this happens every afternoon, or it is highly correlated with the bed occupancy. And these are the patterns and trends. So usually very often when you present this data to someone, somebody would say that, oh, it is related to bed occupancy, why not increase the number of beds? Or it says it happens every afternoon, oh, why not increase the number of nurses and doctors in emergency department during afternoon? So let's solve this problem. Let's add additional capacity. Let's add nurses, doctors, and beds. That would be the first thought that would come, in any person's mind who's not looking at this problem in a holistic way. But let's go further down and let's put some structure around it. So why is the patient waiting in the ED? Now the answer is because the ED bed is not available. I mean, that's very straightforward. Why the ED bed is not available? Because a patient is in that bed waiting to be transferred to inpatient unit, right? This is a natural pathway of a patient. Sometimes some of the patients get discharged from ED to home, and some of the patient gets admitted to inpatient. Now the patients are waiting because the beds are not available. Beds not available because couple of patients, let's say, are waiting to be transferred to inpatient unit. Why they're waiting to be transferred? Because the inpatient bed is not available. Very straightforward. Now let's ask further question. Why the inpatient bed is not available? Because the patient in that bed is delayed for discharge. Now the story is shifting. Now we are not talking about the problems and the issues within the ED. We are not thinking locally. Now this thinking is forcing us to think globally, holistically. Now, why the patient is delayed is because the bed is not available. Why the bed is not available? Because the patient is waiting for discharge. Let's ask further, why the discharge is delayed? Because the doctor has not even completed the rounds. The pharmacy clearance is pending, or there's a billing query. So now when we, all of you, some of us who are coming from hospital background, we know that, we have had a very, very good experience in a hospital, a very good room, good hospitality, doctors are good, nurses are good. And on the day of a discharge, a doctor comes to us in the morning and say at 9 a.m., oh, Mohammed Alam, you will be discharged today. and the clock starts and the waiting starts. And he tells this in the morning, maybe at 8 a.m., 9 a.m. By the time many patients leave the hospital, is already 4 p.m., 5 p.m. Because doctor has not put some of the orders. The doctor has not, you know, cleared some of the notes, or the pharmacy medicine is not available, clearance is not there, and very often the delay happen because of the financial clearance at the end. Now we can see how this structure model has moved from the problem in ED to something which is happening in inpatient. Now, what are the mental models? Now the doctor says the EDs. Now let's not the doctor. Let's say if we think that ED's wait time is the ED's problem, that is one of the mental model. Thinking in isolation. Nobody in inpatient will think, oh, what is happening in ED is something related to me. It is what ED is, and they'll keep on blaming ED. And the doctor will say, patient rounds are my priority. Discharge paper work is just admin. I'll do it later. Sometimes the delays happen because the doctor says, I will have a round for all the patients. And then at the end of the rounds, I will sit down on a computer, then I'll make notes and I'll discharge patients one by one, kind of a batch processing. But the mental model, which is forcing him to do this because he thinks what happens with the patient beyond my scope, which is basically doing the patient round and talking to patient clinically. Everything outside this is not my problem. But does the patient take this in this way? The patient is in a hospital and is going through a complete journey. It involves every steps, every stakeholders. So the patient will not leave the hospital say that, oh, I had a very happy experience in a hospital because the doctor was very good, but everything else was very bad. The patient will say that I had a horrible patient journey in a hospital. Now, this doctor, physicians, they need to, of course, think holistically that it is not about just patient round, it is about the overall patient journey. Same way that the financial team will keep on dealing the patient because for them the financial accuracy is more important than a patient's timely discharge. They would take their infinite minutes and hours, to make sure that not even a single rupee or a single real is missed, even if it cost another 2 to 3 hours delay for a patient. Now, this is also a mental model because financial team is thinking in isolation about how does this impact them, and the doctor is thinking about how does this impact him, and the ED is suffering because of everyone is thinking about themselves, how to do their best, but nobody is thinking how their steps are interconnected and linked with other steps of a patient journey. So that's the one of the element. I mean, I would want you to, whenever you face any challenges, any issue in a hospital, in any of the area, so we need to apply this model of systems thinking and figure out how does this event is related to another elements in a hospital. Now, another slide is denying the obvious. The system is never the sum of its parts, it's the product of their interaction. Now, for what happens in, let's take an example of a car. When we have a car, and the purpose of a car is to move from point A to point B. Now, if for some reason the engine, one of the component in an engine stops working, would the car move? Would we able to drive the car? The answer is of course no, right? That means one of the element which is very important for a system to work. If it stops working, we may not be able to run the system as effective as possible. In some cases, it may not even move at all. For example, if something goes wrong in an engine, the car will not move at all. Now, let's take an example. If the air conditioning is not working in a car, it is also one of the important component, but it may not break the system, right? You may get some kind of discomfort, but you may still be able to reach to a destination from point A to point B and finish your journey, but in a kind of a discomfort. But the end of a journey, you will say that, oh, I am able to complete the journey, but I am never going to take this car service again. So same thing happens in a hospital. Sometimes the major components breaks, sometimes a minor component break. So for a financial person, he may think what happens, if I delay a patient by 1 or 2 hours, A doctor may say that what happens if the discharge is delayed for 1 or 2 hours, the patient will still be discharged. And the answer is yes, the patient will still be able to go home, discharge. But at the end of a journey, patient will say that I was able to complete the journey, but it was not the journey I expected, and I'm not going to visit this hospital again. So let's make the best car. Let's take the best engine, which is 1500 horsepower Bugatti engine. It's the most powerful production engine. Let's take the best transmission from Ferrari. Let's take the best brakes from Porsche. Let's take the best suspension from Mercedes-Benz. Let's take the best infotainment from Tesla. And I want you to unmute yourself and contribute to this discussion. Now, my question to all of you is that if I take the best of these best cars and I assemble them, would I get the best car? I want to ask this question to the participants who are here. Would we be able to get the best car? What do you think? Anyone?
No, it's unless the departments interact with each other, it's impossible to get this the best car.
Perfect. Perfect. So let's see what happens when we do this. So as you rightly said, they may not be compatible with each other. So the engine versus transmission, Ferrari transmission is 800 HP, Bugatti engine is 1500 HP. So transmission would be overloaded. It would be a system failure. The engine versus chassis, the sports car frame is too small and it's not structurally designed for a Bugatti engine. So the chassis is weakened and it's again system failure. Now the brakes would not be compatible with suspension because Mercedes suspension is very soft and Porsche brakes are extremely strong. And again, it's a system failure. So what happens? It's a power mismatch, it's a size mismatch, it's a force mismatch. So if let's connect it with the hospital. If every department in a hospital want to be the best, want to become the best, and want to meet their objective, their KPIs, and want to you know uh, get the number one department award in a hospital, and everyone is working in isolation, what we may get in a hospital may not be the best. We may get actually a worst hospital. So let's apply the same concept to a hospital environment, a hospital who's on a journey to improvement, and they're doing a department level improvement initiatives. So let's look at OPD, radiology, pharmacy, ED, OR, procurement, inpatient, L&D. Now, if everyone is working to become the best department in the hospital and everyone is working in isolations without understanding their impact on other elements in a hospital, what would happen is basically it can destroy the organization. As we say, improving the performance of the parts of a system taken separately will necessarily improve the performance of the whole. It is a false. It is not true, as sometimes we think. And whenever we work in a hospital, we have objectives defined for multiple departments without understanding its impact on other departments. Now we'll see very good example, and it's a very classic example how procurement works in a hospital. Procurement job is to save money to the hospital to bring the most cost effective consumables equipments to the hospital, but sometime in hospital they work in isolation without getting the inputs and consensus and buy-in from the clinical teams who are the end user of those consumables. And instead of basically saving some money to the hospital, it actually costs more to the hospital. So let's look at this example. We all know at this point of time that a hospital is a system. We have been talking about system, and it's a patient care delivery system. And the goal of this system is to provide safe, effective, and efficient patient care, good outcomes at a sustainable cost. Now, the myth, as we just spoke in the previous slide, is that the myth is that if, let's say, our purchasing department gets the lowest possible price on all supplies, the hospital will save money and be more profitable. This is usually how many of the hospital works. This is how the leadership defines the KPIs. And let's say this is a myth. If our purchasing department gets the lowest possible price, we'll save money to the hospital. And with this myth, the hospital C-suite tells the supply chain department that your number one KPI is to reduce supply cost by 10%. Then what happens? The optimized action, because the purchasing department head is now very excited. At least they know what they have been asked to do. And then he puts all his effort into finding the right suppliers in the city, outside city, and to find the alternate consumable supplies. And they were able to find new supply for sterile gloves that are 15% cheaper. As we all know that in a hospital, the gloves are also one of those consumables which has a very high volume consumption. And they look great on paper, and the manager is praised for meeting the KPIs. So instead of saving 10%, the department was able to save 15%. Fair enough. Now let's look at the story of this cost saving gloves. What happens to the hospital? The clinical reality is the new gloves are stiff and slightly less durable. Okay, then what happens? Now, what happens? Because it's stiff and less durable, everyone started doing the double gloving because they don't believe in the integrity of the glove. So started double gloving. That means double consumption. That means it's a waste. So now the consumption has basically become twice. What happens in other areas? Because during a procedure, there were some incidents of glove tear, and every time this happens, it wastes another 3 to 5 minutes of operating room time because you need to change your gloves. And everybody in, I think, believe know that how expensive it is to run an operating theater. Any minute wastage is a tons of money wastage in terms of the cost of the surgeon, the cost of nurses, cost of equipment sitting idle, and the cost of using the whole OR as a facility. And the safety risk. Now sometimes the tear is so micro that nurse did not even notice it, and what happened, it increased the surgical site infection rate. So, the procurement took one action and they were happily, praised, and they met their KPIs and they got the award as well, the number one department. But the ripple effect on the system was that it has impacted multiple components of a system. Now we have a double consumption, we are wasting OR time, but most importantly, it's a safety risk to a patient. Surgical site infection has increased. So what have we done? What have we done to this? The hospital is now less safe, less efficient, and more expensive. The supply chain department successfully optimized its part, but in doing so, it destroyed the performance of the whole system. Now, this is what happens when we don't apply the system thinking in a hospital. When we think, you know, uh, of each department working in isolation as a standalone component, but that's not the story. Like a car, when everything has to work together, like an aircraft, where actually every component has to work with each other to deliver the exceptional customer experience, to deliver the output. Similarly, in a hospital, every department has to work with each other, connected with each other, in a sync if you want to deliver something exceptional good. So I'll not go through this, but but later on you will have an access of this video recording as well. Sometime we try to increase the utilization of MRI, CT scan in a hospital. Why it is not utilized, and sometimes we pack the schedule 8:30, 9:30. But what happens sometimes we have patients who are aged, who take some times, who are complex, or then it has a cascading effect on multiple patients, wasted staff, wasted porter. So I'll let you go through this later on when the recording would be shared. But again, it's the same concept. By trying to use the machine 100% of the time, the hospital ensure that flow of the patient stops. Moving on. In any system, let's conclude this, the behavior of each component has an effect on the performance of the whole. When we optimize individual components, we degrade the system's overall performance. It is okay sometimes, it is okay sometimes to degrade some of the process performance. You may have to have sometime, let's say, more porters in a hospital because you want to make the patient flow smooth. But if somebody looks at why this department is spending so much on patient porters, let's reduce the number of porters without understanding its impact on the smooth flow of a patient, then it's a problem. So sometimes we need to sub-optimize some of the components if we want to make the improve the overall system performance better. And I think this is one of the example I always talk about. And OR process, when we ask someone how does the OR process looks like, and I believe Miss Raquel is here. She was part of this journey when we were together, and this is one of my best example and one of the best success stories that I always talk about. When somebody asks what does the OR process looks like, somebody will say that, oh, it's patient out, patient goes out of the room is clean, room is prepared, patient comes in, surgery starts, surgery ends, and it looks like a very linear process. It's a very linear process, very straightforward process. But actually, when we observe the process in OR and we understand, it looks it looks like this. There are so many inputs to this process. Flow unit is basically patients, and it's a network of activities. Then there's a process management, there's an information structure, there are a lot of information communication happens between multiple stakeholders. There are a lot of resources are used, a lot of equipment, supplies, consumables. And throughout this a maze of a process, some of the activities are value adding activities, some of the activities are non value adding activities. So eventually when we see an OR, a patient goes out, next patient comes in, and it takes 30 minutes, 40 minutes. It is not because it is supposed to take that much of time. It is because of, there's a lot of coordination, mismatch of information, and there are many activities which are non-value added activities being done during this process, which creates this delay. So whenever we want to improve any process, I think there are two questions that we need to ask ourselves. In a hospital, let's say, is patient care process broken into individual activities? Is a standard time defined for these activities? If you want to improve this OR process, how long it takes, when the last patient goes out and the next patient comes in, how long it takes between two cases. First of all, we need to understand what happens between these two events. What are the steps? What are the tasks being performed by the nurses, surgeons, anesthetists, technicians, housekeeping staff, and how long it takes for them to do this? Until and unless we don't break down this whole mess of an activities into these smaller steps, smaller tasks, and quantify them, we'll never be able to understand what is which step, which task is eating up the time, which is causing the delay. So same concept as we see that, a Formula One pit stop, a lot of people come together, they have a defined task, they know what to do, they know the sequence, when to do, and they know how long it is going to take. And they're able to do this in sync with each other. Some things are being done in parallel, some things are done in series. And they are able to do this pit stop in a matter of few seconds. Can somebody tell us how long it takes? What is the fastest pit stop time? Can somebody tell how long it takes for the team to change 4 tires?
30 seconds.
Okay. Any more guess? Any other idea? Okay, all right. The fastest pit stop time, I mean, as far as I know, the last time I saw is 1.84 seconds. The Formula One car stops, the tires are taken out, the next tires are fitted in, and the car moves in 1.84 seconds. All of this. Now, all of you, some of you, who say it's not possible, after the session, you may go and watch a video, fastest pit stop, and then you see how fast it happens. Now, the same concept we can apply in operating room. Let's say single minute exchange of dies. We applied the same concept, basically deciding what activities can be done outside. Basically, when the operating room is still being worked upon, the patient is still inside, and what activities can be done in parallel, what activities, oh, we need to stop the operating room to do these activities. So first of all, we understood how the changeover looks like, and then we separated those activities into external activities and the internal activities. And then we started converting those activities, internal to external activities, so that while the OR is still being operated upon, we can streamline those activities. And then we started thinking what activities can be eliminated altogether. Now, this whole process, I mean, SMAD is a concept which is used in industries back, when we used to change manufacturing one part to another. So a lot of dies and a machine and setup used to be changed, dies needs to be changed. So it used to take a lot of time to just shift from one part to another part. So they started thinking, what can we do to streamline this? And the single minute, it does not mean that it has to be done in 1 minute. It means within 10 minutes. So basically a single digit minute kind of thing. So we thought of how can we apply the same concept in an operating theater, and how can we look at all the activities. And initially what used to happen was that some of the, for example, when we want to switch the OR from patient A to patient B, so all of the activities for patient B will start when the patient B is inside the OR. Now, during this time, the surgery is not happening. During this time, the surgeon is ideal. During this time, what is happening is we're doing the setup, we are doing the verification, we are opening the sets, we are doing all those activities, when actually some of those activities can be done in advance, or some of those activities can be done in parallel. So we work with the OR team, with the nurses team, and the leader of that nurses team, I believe she's still here. We worked on this project. We defined what does it take to switch an OR from one patient to another. We broke down all these steps that is being taken. We broke down the steps to a level, how long each step takes. We identified all the stakeholders, and then we decided how should the flow looks like. It looks a little bit complicated on paper, but actually the people, like a Formula One, when you see a Formula One pit stop, you will find it, oh, it's so confusing, so many things happening at once. But those are people who are expert in doing their job. So they know what they're doing and they know how they will do it. Same way, it looks a little bit complicated to us. But when you ask a nurse, and you ask anesthetist, or you ask a surgeon, they would say, oh, I know what it is. They would understand it in a very easy, clear way. But the most important element is that with this framework, we define that how long each step should take, and what should be the sequence of each step, and what should be the responsibility of each stakeholders. Now, after doing this, we were able to improve the room turnover by around 8 minutes. FCOTS is first case on time start improved to 75. Patient turnover reduced by 25%. Now, 8 minute reduction, it looks very negligible, but when you multiply it by number of opportunities you have in a year, you're doing 4 cases in one OR, you multiply 8 by 4 cases, and then your 7 ORs, you multiply it by number of ORs you have. So it translates to a huge number of potential savings in minutes, which can fit in around 667 cases, which is potential additional capacity of, let's say, Saudi Arabia 20 million. The point is that by doing that small improvements in a process, by applying a concept from another industry to a hospital environment, learning from other industries, we don't need to open additional ORs. We can optimize the capacity, we can generate additional potential capacity, and we can take in more cases. So this is how those concepts from other industries, helps healthcare industries as well. This is one of the examples. Now I'll move to another very important concept, which is a discharge process in a hospital. And it's usually a pain in a hospital. I mean, patient goes to a hospital, admitted in a hospital, but on the day of a discharge, what happens with the patient, only patient can tell, because he has been waiting and waiting and waiting to be discharged. So, and usually I believe discharge process is a true test of a system's thinking. The reason is that because there's so many stakeholders involved around the patient during this process. It is a physician, it is a nurse, it is a pharmacy, it is a patient, admin, finance, operations. Now, at this point of time, when the patient is about to be discharged, everyone has to work with each other. And this makes this process very complicated, and that is the reason very often when these components are not working with each other, it gets delayed, the process gets delayed. But having said that, I'll give you an example of what traditionally happens. Now, the traditionally happen is that, let's say there are 9 patients, and the patient will do a rounding of a patient. The rounding will happen at 8 a.m., 8:15, 8:30, 8:45. Let's say assume the physician will take 15 minutes of for each patient. Now, in a traditional way, what physician will do is that physician will complete all the patient rounding. As you can see, the physician started at 8 a.m. and finished the final patient at 10 a.m. Then he will go and sit down, somewhere in a corner on his computer. Then he will start writing the discharge orders. 10, 10, 10, 15. As you can see, this patient, the patient one was seen at 8 a.m. and the discharge order for this patient was written at 10 a.m. because the physician, for his convenience, he would like to do in batches. He would like to see all the patients first, make certain notes, ask his assistant to make notes, and then sit on his computer and start writing the discharge order. A discharge order, let's say, take 5 minutes, and this is when the journey starts. Now, after every discharge order, nursing clearance happens, pharmacy happens, financial happens, and I'm putting some time above based on the experience it takes, 15, 20, 20, 15. And finally, if you see, the first patient will take around 3 hour 33 minutes for a discharge process to complete. Another patient 3 hour 33 minutes, third 3 hour 42 minutes, because it becomes a bottleneck. The discharge orders are done in a period of 5 minutes, but as you can see, nursing capacity may not be enough to match this intake. The nursing clearance takes 15 minutes. Same way, pharmacy take 20 minutes. So at some point of time, it will create a bottleneck. That is the reason you can see this time is varying. And eventually, this is how long it takes. And you can see that the patient rounding, the doctor initiates all the discharge. Now compare it with a single piece flow. What happens if a doctor, instead of rounding all the patients, instead of after each round, takes 5 minutes and write the discharge order. So you do the rounding at 8, you write discharge order at 8:05. You do the rounding another at 8:20, finish rounding 15 minutes. Then you write the order, finish it by 8:25. So now what physician is working on a single piece flow instead of a batch processing. And after seeing every patient, he is putting the discharge orders. So how does this impact the discharges now? Let's see. We have done this exercise. Now, this is the before patient discharge times. The first patient gets discharged at around 11:15, 11:20, and then so on. But as you can see below, when the physician does the immediate discharge order after doing the rounding of patient one, and because now when the discharge order is written, nurses can immediately start working on it, and the pharmacy will work. Nobody would be overloaded because now they have got some buffer, and the first patient get discharged by 9:15 a.m. and so on. And you can see that it's a 59% reduction in discharge lead time just by doing nothing, just by implementing a very basic concept, improvement concept of it basically, I might be wrong, but I have in Toyota's, I mean, books and Toyota's trainings, they have focused a lot on making a single piece flow instead of batch processing, because batch processing builds a lot of waste into the process. It creates bottlenecks at multiple steps of the process, and it itself is not efficient. If something goes wrong, in a batch, for example, then if we look at the industry example, let's say you're doing a batch processing and the first batch goes to next process. And if something are observed, oh, there's something wrong in this batch, the whole batch has to be rejected. But if it's a single piece flow, if something goes wrong, you stop the line and you fix the process and then you run the line again. That's also equally applicable in a hospital environment. So a batch processing is basically in builds a lot of waste in the process. It delays the whole process of discharge. And by switching only from batch processing to a single piece flow, we can just, by doing nothing, with the mindset only that physician think it is convenient for me to do run batches, instead of a mindset, what we need to think is what is convenient for a patient, and let the physician adopt a single piece flow, and we can reduce the discharge lead time by around 60% straight away. And this is the results, and the results speaks for themselves. It is not just improvement in the time, it also reflects in the patient satisfaction as well. I think this is my last couple of slides. Waiting time is a chronic problem across the hospitals, and this is what I have seen is that people talk a lot about in the conferences about waiting time. We should not make the patient wait. Mr. Arshad, let me just finish this waiting time slides, and I'll allow you to ask questions. Yeah. So, and people rarely talk about how do we improve the waiting time. So my question is that, I mean, I was in a hospital, and I was seeing that there was a team, hospitality team was adding chairs in the waiting area in a pharmacy, and I asked, what are you doing? And he said, because a lot of patients are waiting, so I'm adding extra capacity. The point is that we don't need to manage the waiting time, we need to eliminate the waiting time. Now when we look at a as an industrial engineer, when we look at the waiting time, what is a waiting time? It's a formation of a queue. And when does the queue forms? Queue forms because when the patients are coming to a hospital, let's say patients are coming to a pharmacy, right? And they come at a random arrival rate. We cannot predict how many patients will come at what time. We can somehow guess with the historical data, but we cannot predict exactly. At the same time, pharmacists are serving the patients. Let's say each pharmacist will take at least 5 minutes to serve a patient. That means that means a pharmacist can serve maximum 12 patients in an hour. But let's say some of the patient may be complicated. So let's take the capacity of a pharmacist is 10 minutes. If you have three pharmacists, 10 multiply 3, that means in an hour, their capacity is 30 patients to serve. Now, if during an hour there are 50 patients coming, it's a clear mismatch. No matter what you do, you motivate pharmacists, you give them rewards, awards. No matter what you do, you can never have a situation where actually pharmacists would be able to serve that many patients, because the process time itself is 5 minutes. Their capacity is 30 minutes. So why the waiting happens? The waiting happens because for a simple reason. Whenever the arrival rate is greater than service rate, there's a waiting. If you have 50 patients coming in and you can serve only 30 patients, the patient will wait. But if the arrival rate is less than service rate, if you have 40 patients coming in and your service rate is 50 patients, that means there's no queue. It's a very simple mathematics, and this is usually in a hospitals we find it difficult to apply because we have not adopted these concepts in a hospital. Now, arrival rate, as I said, it's very unpredictable. You can predict arrival rate, but service rate depends on two elements. One is the process time and resources. Very often in a hospital, you want to improve the waiting time. Somebody would immediately ask, I need more people, I need more resources, I need more resources. But as you see, there's another element to the service rate. You can still improve your service rate by improving the process time. And that we should do first. We should first focus on, like we have done in OR, we have not added extra ORs. It is very easy to add extra surgeons, extra nurses, anesthetists, but it is very difficult to improve the process sometimes. But having said that, if you want to improve the service rate, let's not look at the resources. Let's look at the process first. Again, coming back to the same slide where we said that for a process to understand, we need to understand these two elements. First of all, we need to divide the whole process into multiple steps, tasks, and then we need to quantify how long each step takes. And then we need to apply the improvements. Now, if you improve the process time with the same resources, for example, before it was taking 5 minutes for a pharmacist, now it is taking 3 minutes. That means from a capacity of 12 patients, you have increased the capacity to 20 patients. Now a pharmacist can serve 20 patients. So basically now 50 patients coming in with the three pharmacists, your capacity has become 60 patients. You don't need to add extra resources. You can, and you eliminate the waiting time, you eliminate the queue. So focus on what you can control and starting with the process time, not on the resources. So we use, I mean, there's a queue model. You can search it online as well. I mean, if personally you want, you can always text me on my WhatsApp. I'll be able to share this model with you. It allows you to enter the arrival rate, your service rate, and with the statistical model, you can figure out how long, what is the probability of length of a queue, length of a system, waiting time in minutes, waiting time in a system, the system's utilization. So it helps you come up with a optimized number of resources that you need. For example, if my arrival rate is 8 and my service rate is 10, even if it is more than 8, because as I said, there's a variability in the arrival. It does not mean that, oh, you will have 8 after, a regular interval. You will have a random arrival. So if I work with one pharmacist, I say, oh, I can serve 10 and only 8 patients are coming. I will, at some point of time, the model will fail. Even for this, I need to have two pharmacists. This is what the model is saying. With these two pharmacists, the average waiting time in a queue would be around 1 minute. As you can see, WQ, and the waiting in system would be around 7 minutes, because 5 minutes the pharmacist will take to serve. So you can use these mathematical models to make better decisions. And in the end, any process that you want to improve, look at from the lean thinking point of view, lean based point of view. Every process is having inherent lot of waste into it. Some are not adding any value to the patient or to the internal stakeholders. And this is not the patient journey we want, which is filled with a lot of waste. And we need to apply the concept of lean thinking. We have multiple sessions, I think couple of sessions before, which is already available on the YouTube channel, talking about lean waste and lean thinking in healthcare. So every process that we want to improve, we should look at it from the lens of lean thinking. So I'll just wrap this up. I do not want to go into other slides, but this is very important. Whenever you go to an hospital, you would find people who are busy working, doing their job. But if you want to improve, you need to, and we need to take some time out of our busy work, because if we don't stop, we don't look back, we don't, introspect what are we doing at the moment, actually will not be able to improve. So improvement needs dedicated time. Otherwise, you will be busy. I mean, everyone is busy. You will ever always be busy. I mean, as you can see, this person, these people are busy and they will leave home. Oh, we have done so much of work today and we are busy. We were busy. But actually, there's always some better way of doing the same work. You can always improve it. There's always an opportunity for improvement. But if you're not getting better, you're getting worse, because somebody somewhere in a hospital must be working to improve their processes. But if it is not you, then that means you're getting worse. And as I always say, there's always a best way of doing everything. And this is my last slide. And the last slide is usually I ask a question to the audience. What do you think is the biggest room in the world? I want all of you to guess. What do you think is the biggest room in the world?
Your mind.
Okay, what else? Any other idea? Just guess. What do you think is the biggest room in the world?
Waste.
Okay, waste. All right, I'll just show
I
it
mean,
to you. It is the room for improvement.
Yeah.
Nothing is perfect. Every process, even us as an individuals, even we are not perfect. Always there's a room for improvement. So always go with this mindset, that how can we make this even much better. So it's a pursuit for perfection. Nobody is perfect, nobody will ever be perfect, but it is always this journey of continuous improvement with the right mindset. So with this, I'll close my session today. So uh, let's, if you have any questions, I'm here, let's discuss. If you have any questions, anything you want to ask, and then we can wrap up. Please.
Mr. Mohammed, thank you so much. Are you going to have weekly or bi-weekly sessions, or this is on?
Actually, my intention is to do it every 2 weeks now, because earlier, I was trying to do it every week, which becomes a little bit heavy, not only on me, but on the audience as well. But we probably might have every 2 weeks one session. Yeah.
Okay, that's great actually. Very good.
Thank you. Dr. M, you want to add anything, please?
Yeah, let me, am I audible, right?
Yes, you are.
Yeah, Dr. M, I'm not a clinical doctor, I'm a PhD doctor. So one thing is, I love the session that you did. Secondly, what rings through me and what I've been trying to ask is, if you can give an operational definition for patient, customers, and client, the minute the healthcare looks at the patient as a customer and a client, see what happens. Secondly, all the examples that we do in the healthcare, we take it to automobile. And when we are looking at the engineering, we take the healthcare sector. We call it the surgeon's eye. Okay, when the surgeon is doing the operation, he's not looking at the efficiency at which he's doing, he's looking at the effectiveness of what he's doing. So even if he requires just one anesthetist, he may have two anesthetists. If he requires only two oxygen cylinders, he may require four oxygen cylinders. Therefore, we look at effectiveness, and as you rightly said, localization or optimization of a local thing is harmful. And we take your example. We take that you've got 7 systems in your body, and each are interdependent and interdependent and what do you call that? Interdependent and they are independent and interrelated. And that's equally true of any organization. So we take your example in our organization. And it was a real good experience, Alam. Thank you very much for this. And I used to be challenged when I used to fly from Saudi Arabia, Ductile Iron Pipes, from Daman to Kola Hospital in Muscat. And I tell them that I did the same thing in Ductile Iron Pipes. I'm doing the same thing in Muscat, in Kola Hospital, Muscat. So thank you a lot and congratulations. And we have got a lot to learn from you. I'm going to take this recording to our industries here. Thank you very much, Alam. Thanks for inviting me.
Thank you. Mishari, please. Yeah.
Yeah, thank you, Mr. Alam. Mr. Alam, sometimes we face an issue with patient expectation. Everything is going well, everything is great, but the patient expectations sometimes it's not real. It cannot be happening in any hospital. So how can we, let's say about the discharge process, that patient expectation is once the doctor told him he is for discharge, he's good to go. He wants to go now. But how can we, or is it necessary to reduce the patient expectation?
See, okay, Mishari, I mean, that's a very good point. See, there are two elements. I think first is setting the right expectations. Very often, if you talk about the patient who's expecting, that I will be discharged straight away after the doctor told me I will go home today. Very often, the patient is not even told how does the process looks like, right? For example, I'll give an example. When you are in a flight, and very often you have seen that, including me, many of us, we open a screen in front of us, which tells us where is the flight right now. It tells us on a map where the flight is right now and what is the expected time of arrival, what is the speed, and what is happening. Now, when the patient comes to a hospital, he's totally blind. He's on a mercy of, actually somebody telling him, but only when he asks someone what is happening. Very often the patient comes, the patient relatives go to nurse, how long is going to take? What is happening? How long is going to take? Now, it is not just about setting the right expectation. For example, if the process takes 120 minutes, we tell the patient that, the process is going to take 120 minutes because it goes through the nursing clearance, pharmacy clearance, financial clearance. But not that is important, but it is also important we let the patient know that where is the process right now. How can we make it visible for the patient so that patient knows, oh, right now the pharmacy clearance is going on. For example, in Saudi Arabia, we have hunger station, right? We order food. and it tells us the food would be delivered in another 30 minutes. But when we go into the app, we are able to see the restaurant is preparing the food. The delivery boy is now reaching the restaurant to collect the food. The food is collected, and then we also see where the delivery partner is at the moment. So, and we don't raise any questions, we don't ask anyone, oh, how long is going to take, because we know what is happening in real time. Same thing we need to do in healthcare. After setting the right expectations, we need to make it visible and transparent to the patient where is the process at the moment and how long is going to take, so that patient knows themselves, and then this problem would probably be resolved. Perfect. Anything else? Any other questions? Yes, Dr. Weil.
Assalamu alaikum, everyone. Really, thank you, Adam, for your wonderful presentation. My concern and my question, because I was working in inpatient before. Sometimes the process is stated and everything is fine, but patient refuses to be discharged for any reason, because of the delay, for the inconvenience, for the transportation, and that might negatively impact on the patient discharge at the time the discharge process and delaying other patients from being admitted. So my question, because you speak about the process from the admin and from the staff point of view, my question is, what is about the patient for the process and expectation, and how we can get share it, the know about this process and you too.
Yeah, so I think, see, I mean, as it's everything is not as perfect. Nothing is perfect. No process is perfect. Even if you do everything right, as Dr. Weil said, there might still be some component, which comes out of nowhere. The patient says, "Oh, my driver has not reached yet. Oh, I want to have a food. I want to have a bath. I do not want to go right now. I don't feel good." There's so many elements. That is why when we work in a systems, we work in a system with a reasonable buffer. The buffer acts as an absorber for these kind of variations, but that has to be done statistically. That should not be done just based on some random observations. We need to understand, in the last, say, 100 patients, usually these would be outliers. Not every patient would say that my driver is delayed. In a hospital, it is always a 80-20 rule. 80% of the patient would always be like a normal patient. 80% of patient would always be, going through a normal process. There will always be 20% of the cases which will go through something which was unexpected. The discharge got delayed because of some system related issue, some medications not entered by the doctor, wrong medications, or the patient himself doesn't want to go. Now, for those 20% cases with a variation, we need to ensure that how do we build some buffer in the system itself, so that we don't choke the hospital. No system, I mean, if you look at, let me give you an example. If when we when the airplane is flying, the engines are operating. The engines are not operating at their 100% capacity. They are like operating at maybe 50-60% of the capacity, but they go through a severe weather conditions, their capacity goes to 90%. Same way, when you see our car, when we're driving on a road and a normal speed, our engine is very relaxed. But when we need to overtake someone, we push the accelerator, the engine goes to a capacity of 90%, 100%. You see the RPM. Same way, in a hospital environment, we need to understand what is our normal operating range. And we need to understand what is our stress operating range. And we need to build some capacity as a buffer. We should make sure that, if you have 150 bed hospital and we have 150 patients admitted, if anything goes wrong in 10 patient cases, the 10-20 patient cases who are waiting outside to be admitted will create a bottleneck, and it will be a mess for a hospital. So we always need to maintain some buffer capacity. Yes, Dr. Weil. I hope
Yes, that's clear.
Yeah.
That's really clear. Thank you.
Anyone else? Yes, Arshad, please. Arshad, you may ask now. I can see your hand is raised.
Okay, sorry, my mic was mute. Thank you very much for the session, Mr. Alam. It was a very nice session, actually, and I hope it has been recorded and will be shared soon. I have a question when you explained about the single flow and the batch process, right? So I believe you have improved it in your hospital as well. My curiosity was, uh, and then we discussed how the demand and capacity uh, can have a balance. I mean, there, yes, we divide the resources into two. I mean, in the service in two: resources and process time. But there should be some threshold, I believe, where we can strike a balance between when to go for increasing the resources, number of resources. So, is there any clear rule of thumb, or how you are going to address it?
So I don't know about the industry standard, what is the clear rule and thumb of rule, but I use one logic whenever I propose to leadership. Whenever the system hits 80% or 85% utilization capacity, I recommend adding additional resources. Because then we as I was answering Dr. Weil, if you're hitting 80 to 85% capacity and you are left with only 15% buffer, now any spike because of any sudden rush of patients or anything will choke your system, will block your system. So for me, the thumb rule is 80%. If the resource is 80% utilized and only 20% left, add another one.
Thank you. Thank you. That's about utilization. Yes, that makes sense. Yes. Thank you.
So sorry, Alam. So for that reason, you are using the resource plan with the utilization rate to address that, right?
Yes.
Do you have any material that you build for that resource plan?
Dr. Weil, I will share with you when I look at look at the resource requirement. How do I compare the demand versus capacity? I have a couple of templates that I use. I'll be happy to share it with you. Yeah.
Thank you.
All right. Anyone else? Dr. Mohan? Yeah. You're on mute, Dr. Mohan. You are on mute. Yes. You
This
are on
occurred to
mute.
me, yeah, it just occurred to me that all of us should be aware that in any processes or system as such, we interchange that language. There are common cause variations and there are special cause variations. So we normally don't go by the averages. We go by the upper limit and the lower limit of the control charts, and we should never mistake special cause variation for a common cause variation and vice versa. And you are aware of it, of how you do it, and you're doing extremely well. So this variation will happen, but then they are common cause variations, right? I'm
Yeah.
sure you will be talking to them about it. And thank you very much again for inviting me. I'm looking forward to more.
Deirdre, sorry, I'm not able to spell your name properly, pronounce your name. Please. Yeah.
Thank you very much. I'm Deirdre Pansacher. I'm a pediatrician in South Africa in the health system. When you were talking about the public, the utilization, in the public health system, we are struggling quite a lot because the CEOs are very reluctant to adjust their beds, their usable beds. It seems like they are scared that that will influence their finances. But my understanding is that the usable beds must be basically worked out based on your demand. And yeah, so if you have resources about that, that would be very helpful, because it's been quite difficult to try to convince people to adjust their beds because they worried that they're going to lose funds. But then their bed utilization keep on being very low because they don't want to adjust the beds.
All right. So I think, Deirdre, I would be able to better answer this, because I think this needs a little bit more understanding of your context. So I'm dropping my WhatsApp number in the chat box. You may connect with me on my WhatsApp, and I think we can discuss about this particular situation. Yeah. Perfect. All right. I think we're already 15 minutes beyond our time, but I'm happy to see that there's so many questions that came in and so many people have joined in. I think around 14, or we're total 15. Starting after a long period of time, I was not expecting such a healthy turnout, but it turned out to be very good. It's motivating for me as well. So we'll continue to have these sessions every 2 weeks. I'll try to have it on Saturday. And my contact is with you. If you need anything, you can always connect with me personally and be part of this community as well. I wish you all the best and a happy weekend, happy day ahead. So I'll stop the recording and I'll share the recording with all of you on the WhatsApp community group. You can access this anytime. Okay. Thank you, everyone. Have a nice day.
Thank you, Mohammed.